You're doing the even ones on 7.7 WSP, and you need to know, you need to be able to tell when it's arithmetic, when it's geometric, or when it's neither. Again, arithmetic has a common difference, D. Geometric, the one that we're dealing with these days, has a common ratio, R. So you need to know that, okay? And you find either one of those by picking a number and then subtracting the previous one from it. That would be a common difference. Or picking a number and dividing it by the previous number, okay? So you have to do that on each one of these. So if we look at number 2, if you pick 3 halves and subtract 3 from it, okay, 3 halves, subtract 3 from it, you could actually do that on a calculator. Or you could even do this in your head. If you think about 3 halves, that's really half of 3 is 1.5. 1.5 minus 3 is equal to negative 1.5, all right? Or a calculator, you could do that. So if it's a common difference, I say difference because we're trying to subtract here, it should also be true between all of the terms. So if I were to take 1 and subtract the previous one from it, let's do that. I want to do this one in blue. 1, take away 3 halves. 1, take away 3 halves. So that's really 1 minus 3 halves is really a 1.5. 1 minus 1.5, that'll be negative 0.5 if you do that on a calculator. And as you could see, this difference and that difference are not common. So there is no way that number 2 could be arithmetic. So that kind of eliminates the possibility of it being arithmetic because there is no common difference. Again, the word common difference would mean that if the difference between these two are negative 1.5, then the difference between these two need to be negative 1.5, and the difference between these two need to be negative 1.5. And as you can see, there is not a common difference. So let's move on to checking if there's a common ratio. So if I pick 3 halves and divide it by 3, checking for a common ratio, 3 halves divided by 3. And when you have fractions and division, all you have to do is change the division to multiplication and flip the second fraction. So there's a 3 right there. Put it over a 1. The first fraction is not going to change. It's still going to stay 3 halves, but you're going to change to multiplication, and you're going to change that 3 over 1 to 1 over 3. And now you could multiply the top with the top and the bottom with the bottom, or you could cancel the 3's out, and you'll have a 1/2 left over. So far, we have 1/2 as the ratio. What we need to see is that it's in common in all of its terms. Okay, so we did this one divided by this one. Now let's do the next one. 1 divided by 3 halves. Let's see if that works. So 1 divided by 3 halves. Now remember, dividing by a fraction is the same thing as multiplying by the reciprocal of that fraction. So multiplying by 2/3. So if I go 1 times 2/3, what will I get? 2/3. And as you can see, this ratio is different than that ratio, so it does not have a common ratio either. So there was no common difference, right? We tested the difference over here. They were not the same. There was no common ratio here or here, so it's neither. Number 2 is neither. And of course, you could always check the back to see if you did it correctly. I said, I recommend you try all of them. The answers are on the back on all of them. But I assigned the even ones, so you have to at least do the even ones. So what do you guys say here? Is this a common difference or common ratio? It's neither again, right? Because if you try 4, take away negative 2, that's really 6. And if you try negative 6, take away 4, that's negative 10. There is no common difference. There is no difference. Okay, so now let's try see if there's a common ratio, and we'll see that doesn't work either. So on a common ratio, if you take 4 and divide it by negative 2, 4 divided by negative 2, that gives you a negative 2. And then if you try negative 6 divided by 4, negative 6 divided by 4, that's not negative 2. So it's not going to have a common ratio either. So once again, it's neither. But you have to check all the terms, all right? So like if you have a common difference here of 2, it has to be here and it has to be there. All right, so just keep in mind, in order for it to be common, it really does have to be between all the terms, the common difference or the common ratio. All right, let's move on to number 6. A lot of people seem to be struggling with number 6. Now, they tell us that this sequence is geometric. And what does that tell you indirectly? It's telling you that it has a common ratio. Okay? So we know it's geometric. We know there has to be a common ratio. You don't have to check if there's a common difference or a common ratio. They tell you it's geometric, so they're telling you that there is a common ratio. Question is, how do you find the common ratio? Well, you take the number, and then what do you do with that number? You divide it by the previous number. So the common ratio is going to be negative 12 divided by 2. And that's negative 6. So over here on the side, r equals negative 6. That is my common ratio. And once again, you get it by taking a number and dividing it by the previous. Okay? Let me erase this to make... Actually, I'm not going to erase it. I'm just going to write this down. This was my first term, which is a sub 1. This is my second term, a sub 2. This is my third term, a sub 3. And they want us to find the next three terms. So I want to label it a sub 4, a sub 5, and a sub 6. Those are going to be the next three terms on this list. Now, the common ratio, if you understand what arithmetic or geometric sequences are, the common ratio is what gets you from one number to the next. So right here, let's start with the number 2. How do you get from 2 to negative 12? With that common ratio, negative 6. So 2 times negative 6 gets you to negative 12. Negative 12 times negative 6 gets you to positive 72. So how am I going to get from 72 to my next output? Exactly. Multiply the 72 times negative 6. And on a calculator, you get negative 432, right? So let's write that down, negative 432. And then from there, how am I going to get to my next output? Exactly. You're going to take that answer, negative 432, and multiply it by negative 6. Of course, I'm doing this with the calculator. That'll give you a positive 2,592. And finally, for the sixth number, which is going to be the biggest one of them all here, we're going to multiply it again by negative 6. And that'll be negative 15,552. And those are the next three terms. There's really nothing confusing about it once you understand that there's a common ratio between the terms, which means that you multiply by that common ratio. If there were a common difference, you'd be adding or subtracting by the common difference. But right here, common ratio, you're going to be multiplying. Okay, so let's move on now to the next even number, 8. It's over here. And what's the common ratio here? 7, right? How'd you figure that out? You take any number and divide it by the previous number. So the ratio is 28 divided by 4, so the ratio is 7. 7's a magic number on this guy, because that tells you how you get from a sub 1 from your first term to a sub 2. 4 times 7 is 28. And then 28, the a sub 2 term, you multiply it by 7, and you'll get your a sub 3 term, which is 196. Now, how are we going to get the next three terms? Here's a sub 4, a sub 5, a sub 6. So how am I going to get the fourth term? I'm simply going to multiply with the calculator 196 times that common ratio 7, and it'll be 1,372. And to get to the next one, I take that 1,372 and I multiply it by 7 again, and I'll get 9,604. And my final one, multiply 9,604 by 7 again with the calculator, and you'll get 67,228. And those are the next three terms. Pretty easy? Okay. Now, it wouldn't be so easy if they asked you find the 20th term or find the 18th term. You don't want to be doing all that on the calculator. That's when the formulas come in handy. And let's look at the next part of our homework. That's when you need the formula, the a sub nth rule. So we're doing the even ones. Let's jump to this one. And, well, first of all, let's write down the formula, the a sub nth rule for a geometric sequence. And we should all remember that the a sub nth rule is a sub n, that's just the name of it, equals. Now, whether it's arithmetic or geometric, they all start with the first term, a sub 1. But if it were arithmetic, we'd know that we'd be adding to get to the next term. But since it's geometric, we know we're going to be multiplying to get to the next term. So it's a sub 1 times that common ratio, which we find by taking a number and dividing it by the previous, and it's always to the n minus 1 power. That's the a sub nth rule for a geometric sequence. So which one's a sub 1 out of these three numbers up here? Right here, which one's a sub 1? Exactly, the first one's a sub 1. So this is the first one, second one, third one, and so on and so on. Now, a sub nth, what that means is that you're going to be able to find any number you want. It could be the 17th term, the 20th term, but this is the rule that we use to find that 18th term or whatever term we want. But anyways, let's complete our rule. It's going to be a sub n, a sub 1 is 3,584, and then we need to multiply it by r. But the thing is, what is r? Well, let's find out what r is by simply taking a number and dividing it by the previous number. So I'm going to go 224 divided by 896. Let's first try it on a calculator. 224 divided by 896. And if you have a Texas Instrument, it'll show up as 0.25. If you have a Casio, it'll tell you the reduced fraction is 1/4. So that reduced fraction, the r, is 1/4. Okay? R is 1/4. Now, what does that mean really? It means that that's how you get from this number to the next number. This times 1/4 is 896. 896 times 1/4 is 224. That common ratio tells you how to get to the next number. Anyhow, our equation is a sub n equals, now we still need to fill this out. The common ratio is 1/4, and it's always to the n minus 1 power. That's your rule. Now let's go back and see what they ask us besides stating the rule, the nth rule. It says find the sixth term, the sixth term. So you can simply find the sixth term by plugging in a 6 right there where the n's at and doing all this on a calculator. Or if you wanted to, you could understand how the list is advancing with the common ratio 1/4. So this times 1/4 is this, times 1/4 is this. There's already three terms. They want the sixth term. So they want the a sub 4, a sub 5. They want the a sub 6 term. So you could do it by simply multiplying by 1/4, multiplying by 1/4, and multiplying by 1/4, right? To get from here to 24 times 1/4 times 1/4 times 1/4. You could do it that way, but they would like to see you actually use the formula. Let me show you how you'd use the formula. Type in 3584 times 1/4 to the, now you're going to plug in 6 because they want the sixth term, but instead of plugging in 6 in your calculator, it says 6 minus 1. So on your calculator, you might as well type in a 5 right there. And if you do that, 3,584 parenthesis 1 divided by 4, close parenthesis, to the power of 5. Because when you plug in 6, it'll be 6 take away 1, which is 5. Hit equal, and it'll give you the answer 7/2. Let me show you. So here we go. There's my calculator work. The Casio does it beautifully. You can type it in. You type in the numbers down here, obviously. Open up some parentheses right here. And then when you open up the parentheses, you could hit this button right here, the fraction button, and type in the 1 and the 4. And then you hit the sidebar, so it'll go from the denominator to the side. Then you hit the other parenthesis, close it, and then there's this magic button that'll pop it up to the exponent position, and we type in 5. Even though we're plugging in 6, we know that the original formula that we came up with, the a sub nth rule, says n minus 1. So when you plug in 6, it's 6 minus 1, which we know is 5. So that's why I type in a 5. Final answer is 7/2. Now the correct, see, I put 7/2 right here, but I guess the better answer would be this: a sub 6 equals 7/2. Because with this a sub 6, I'm saying that the sixth term on my original list is 7/2. Okay? And the last one, number 12. Find the eighth term of the geometric sequence. Whoa! This one's fun. This one's fun, guys. It's a lot different. You're going to love this one. Now, we know that a geometric sequence has a sub n equals a sub 1 times r to the n minus 1 power. But do they give us a list?
No.
They do not. They don't even give us an a sub 1, and we need an a sub 1. But they give us a sub 3. And the common ratio 7. Okay, so there's many ways of approaching this. Here's one way. One way is to imagine a list of numbers. Let me do it in blue right here. You don't know the first one, a sub 1. You don't know the second one, a sub 2. But you know the third one, a sub 3. And that third one is 35, right? So we're missing the first two numbers, comma, comma, comma. Now, what would a sub 4 be, guys? What would a sub 4 be? With the calculator, that is. If your common ratio is 7. You'd go 35 times 7. Isn't that right? 35 times 7? And that gives you 245 on a calculator. So 245. And you could continue with this to get to the 8th term. So you could continue going, okay, times the common ratio r, get a bigger number, times 7, get a bigger number, times 7, get a bigger number, times 7, till you get to the 8th term. Now that's the lame way of doing it. You're not using algebra right there. You're using a calculator and multiplication. But the better way of doing it is take what you know, and find out what you don't know. So like, I know that my third number is 35. So a sub n is the name of the function that'll give me any number I want. So if I know that a sub n could be a sub 3, like I could say my third term will be based on me plugging in a 3 right here. So if I check this out. Let me write it as I say it. My third term could be a sub 1 times r to the 3 minus 1 power. Do we understand that? If I want my third term, all I have to do is plug in a 3 right here. If I had a sub 1 and r, but I don't have a sub. Actually, I do have an r. So let's do that. Let's say that we're going to do a sub 3. We're going to find out our third term by plugging in a 3 where the end's at. But we don't know a sub 1, but we do know r. What is r? 7. So let's rewrite it. A sub 3 equals a sub 1, which we don't know, times r, which you just said was 7, to the n minus 1 power, but we know it's 3 minus 1. So what do I put as a power? 2, because 3 minus 1 is 2. Okay, I have an equation, but the problem is I can't even solve for a sub 1 yet, because do I know a sub 3? I actually do. What is a sub 3? 35. So let's take that 35 and plug it right in there. We're going to have 35 equals a sub 1 times 7 to the second power. So we're plugging in everything that they gave us to find out what we don't know. So what could we do here? 7 squared is what? 7 squared is what? 49. So you really have, let me go to the side right here. You really have 35 equals a sub 1 times 49. So you could rewrite this as 35 equals 49 a sub 1. Now you don't want the 49. You just want the a sub 1. So you could divide by 49 and you get 35 over 49 as your a sub 1 term. And if on a calculator you go 35 divided by 49, it will give you the decimal 0.714285 repeating, or if you were to use the Casio, it'll give you the reduced fraction of 5/7. In other words, you could reduce 35 and 49 by 7, and it'll become 5/7 if you reduce it by 7. So your a sub 1 term is 5/7. Now, we found the a sub 1 term. And now we really do have the a sub 1. We have the common ratio that was given to us. And we have, that's all we need to make the formula. So let's do that. So a sub n equals a sub 1, 5/7 times the common ratio, which we said was 7, to the power of n minus 1. This is the machine that will produce the original list, even though there is no list. If you wanted to make the list, you could plug in 1 right there. It'll give you your first term, 5/7. You could plug in 2, and it'll give you the next term. Plug in 3, it'll give you 35. And you want the 8th term, I believe. Is that what they're asking for? Yes, 8th term. So you're going to plug in 8 on your calculator. So you're going to go 5/7 times 7 to the 8 minus 1 power. So you're going to put a 7 right there. So on the calculator, 5/7 parenthesis times 7, close parenthesis, to the power of 7. We're going to get a crazy huge number, which is the 8th term. A sub 8 equals 588,245. That was a lot of work. For one problem. But that's the last one we're doing on the homework together. We're only doing the even ones, and that was it.